Hi, everybody. Brian Mungo, Territory Sales Manager for Legrand AV. Legrand AV is one of the foremost manufacturers of AV technology in the world, with 7 different brands of different technology. Today, we're joined by Joe Cornwall, who's recognized as an AV industry educator, author, avid fisherman, and technology professional, and general AV legend with experience in sales. It's true, Joe. Sales, management, technical positions in the commercial, resi, and broadcast AV market. He's done everything over the last 30 years and even wears great hats for presentations. He's an Avixa faculty member, a 2014 Infocom Educator of the Year award winner, frequent presenter at every acronym you can think of, including VIXI, AIA, NSCA, Infocom, and everywhere across North America and around the world. He's a Bearcat from the University of Cincinnati, right here in my home state of Ohio. He holds CTSD and CTSI, ISFC, and FOI certs. And he created the AV Technology Evangelist position, which he holds very dearly here at Legrand, and is responsible for predicting the future and helping Legrand steer and navigate to bring the best products to you and kind of keep us all on the same page when it comes to what we can expect down the road. So with that, I'll kick it over to Joe. Appreciate you all joining us, and let's talk about emerging technologies. Joe?
Thanks, Brian. Good morning, everybody. Thanks for joining us. I promise I'm going to try and keep this as exciting and light on its feet as it can possibly be, because we can definitely get in the weeds with talking about some of this technology. So I want to make sure that we're taking a look at what's happening here in the future. And I want to start by just basically having a little bit of an idea. What is AV in the 21st century? What does it really mean? And here are 3 concepts that I think are incredibly important as we think about the application of AV in the corporate sector. First, it should be intuitive. If you need to hire an engineer to turn the conference system on, it's probably too hard to use, and it should be intuitive for the integration of mobile and stationary assets. We do not live in a world where people are bringing transparencies anymore. They're bringing all kinds of mobile devices. It should be easy to use. There should be unfettered integration of work and personal technology. You don't know what somebody is going to show up with, so systems must be designed not just to operate in a Mac environment or a Windows environment or a Chrome environment, but in any environment that someone may bring to that location. And this kind of AV capability should be uninterrupted in terms of access. It should blur those lines between content and carrier. We're going to get content via streaming, it's going to be coming in via file transfers, it's going to be living on these mobile devices. All of these really have to be accommodated inside of AV design, and that's a very important part of our future. And my slide will change eventually, I'm sure. Once again, one of the fun parts of technology. Come on, little guy. All right, I have no idea what's going on here, because it was working just as, there we go. So we all know that today's technology, its value is directly proportional to its utility. That means if it doesn't work, it doesn't have any value, no matter how much money was spent on it. We've all been into those conference rooms that nobody can turn on. I ask, what is the value of something like that? But I'm going to point out one additional concept. When we think of the silos, the technology that we use for AV, we should be having unity from an individual workspace all the way up to classrooms and training rooms. And there are 4 vectors in AV that we must consider. We really have to put this into perspective. We think about device to device, the Internet of Things. These are actually the machines talking to each other. Right now, your computer, of course, is talking to your monitor several times a second just to get HDCP capable. This is generally where we stop thinking about AV, but it's important for us to also consider that the way that we control the devices, the device to human to device communication, including voice control in corporate applications. These are expectations of the next generation. The way the device speaks to us, applying standards such as Discus to make sure we understand exactly the kind of resolution, make sure that we have good legibility and understandability from audio and video. And finally, and something we rarely talk about in AV, and that is the content, the human-to-human communication. What are we using AV to support? How are we moving this along? And that human-to-human communication is such an important part of that. I guess we're going to be waiting a while for this thing to decide to change slides. I apologize, but we're going to get it as fast as we possibly can. So these 4 vectors, very, very important in terms of really guiding you through your design thinking and what's going on there. My goodness, I have no idea why I'm having such a hard time with this. There we go. Obviously, there's always the question of bandwidth. We almost never have enough of it. So it's kind of important to realize that the United States is 36th in world bandwidth capabilities. The average person has about 135 megabits of bandwidth, and they're working from home. And the other thing that we want to think about in terms of emerging technologies, the Internet of Things is not just a concept. This is growing, and I present to you that most of the Internet of Things really are AV in terms of their capabilities. We're talking about devices that are communicating to a human being via a screen. That certainly makes it an AV type of system. So when we start talking about these interrelated devices that transfer data, we have to be thinking about how they transfer that information to us, the human controllers of these systems as well. I really don't understand why this is taking so long to change, but there we go. Let's talk about mobile asset integration capabilities. And we can't really talk about that until we start thinking about the AV signal quality triangle. I know most of you understand this intuitively, but it's very important for me to point out, when we talk about resolution, we talk about full HD or 4K. Now we have people talking about 8K. Well, the number of Ks, that's just spatial resolution. That's the number of pixels. In reality, when we're talking about resolution, it's really shorthand also for radiometric resolution, bit depth, extended color, high dynamic range. These are even more important than the actual spatial resolution, the number of pixels that you're going to get. And of course, temporal resolution, the number of frames per second that we're carrying, this really defines the performance of the system. So it's very, very important that we balance this AV signal quality triangle, understanding that every triangle is 180 degrees. In order to change the angle of one of these metrics, we have to change the angle of all of them. It's not enough to simply say we're moving to 4K or 8K. We don't have malleable bandwidth to be able to do that. So it's important for us to be able to move on. And now I'm going to jump ahead. So some of the emerging technologies that I think are so important for is Wi-Fi 6E. Now we're beginning to see routers for Wi-Fi 6E hit the market. Why is this such an important technology for AV? Because we now have the ability to go beyond gigabit performance in a wireless environment. With a 10 gig infrastructure, we can actually approach 4 to 5 gigabits per second in wireless performance with increased device capacity. The way that this works is actually quite simple and very intuitive. We all know that Wi-Fi is 2.4 gig or 5 gig. Wi-Fi 6 gigahertz bandwidth. So it's a clean bandwidth, and I believe that this is where our wireless IoT devices and most of our AV infrastructure will survive in the coming years. We can't talk about emerging technology without talking about 5G, right? It's the gorilla that's in the room with us. Let's talk about what 5G really means to AV. This may not be a popular opinion, but I don't think 5G is going to mean a lot to AV. Here's the promises: 20 gigabits per second download speed, 10 gigabits per second upload speed. By the way, if you check your 5G connection right now using the FCC speed test, you're probably going to be in the double megabit per second range. We're not seeing these kinds of speeds being delivered yet. T-Mobile's even said it could be 2024 before we get halfway there. The big advantage of 5G is this decrease in latency. We're talking about latency on the level of the LAN, less than 1 millisecond of latency, which is fabulous, and increased capability. The real opportunities behind 5G as we go forward is going to be this. And I want to bring your attention to the very first quote: fixed wireless, the use of 5G as last mile technology, basically replacing fiber to the home or fiber to the facility. What does this mean for AV? Well, I want you to imagine all of the remote locations, all of the rural locations, ex-urban locations, places where it's impossible for us to really put in a very fast connection to the facility. This will replace microwave links at much lower cost, allowing for at least gigabit capability to some of these fixed capabilities. I think this is where 5G impacts AV more than anything, is our ability to spread our connected communications ability to new locations that otherwise didn't have the ability to enjoy these kinds of speeds. Come on. Of course, I think one of the areas also that we will see in 5G is going to be distributed antenna capabilities will be very important as well as we move forward. But always remember, between wireless and wireless is the wires that make the LAN work. And I want to talk to you a little bit about the AV connection ecosystem. We're going to go up through the bottom of this. This is one of the most important concepts, I think, that I teach when we're looking at this. And we're going to start at the bottom of this with DisplayPort 2.0. As an AV professional, as somebody who's in this industry, you probably haven't spent a lot of time thinking about DisplayPort 2.0 for the most part because it's part of USB Type-C. But DisplayPort 2.0 really brings two things to the forefront that we have to add into our AV infrastructure in the future. The first is capacity for incredible bandwidth, up to 80 gigabits per second on this short link to a docking station. This elevates docking stations to incredible importance. And the second part that DisplayPort brings in is the ability for variable sync rates on content. So we really find our AV receiving equipment, our displays and our installed solutions becoming more complex as these mobile devices become far more complex. It's now possible to go out and record 444 60 hertz 4K capability on a $500 GoPro camera and then to put that on a smartphone. This is DisplayPort 2.0 native technology on that smartphone. Oh my, this is definitely taking a while to change slides. Come on, fellow. You're harshing my mellow here, man. This is AV technology at its best. What's it doing to me next? Well, what it's telling me is that USB Type-C is the future of connectivity. We're basically seeing laptops, smartphones, tablets, conferencing devices, monitors, cameras, all of these devices using the same connector. It is the AV unicorn that we've been looking for years, and we're going to see incredible growth in this. In fact, we're seeing CAGRs that are in excess of 10% over the next 5 years. This is true growth. So what is USB Type-C and why do you need to be concerned about it? USB Type-C is nothing short of magic. That little tiny connector that lives on your smartphone, that lives right on the bottom of a little tiny device like this, that capability has got alternate mode, which can support up to 10 gig wired Ethernet. It can support multiple lanes of up to 8K video. It can support embedded multi-channel audio. It can support power delivery up to 100 watts. It is truly astonishing technology. But guess what's going to happen in your installed AV system? You're going to have just, well, we're going to call it a small, rough road to traverse until we all understand the concept of EMCAs and billboards. What are EMCAs? Electronically marked cable assemblies. Here we are in 2021, and what just happened is the cable, the piece of wire, has now become a component. Because if you don't have an EMCA cable, then the cable stops at USB 2.0 speeds, 480 megabits per second. But I just told you that we're going to have up to 80 gigabits per second. This requires active cables properly marked and billboard chips in the devices that will allow for negotiation. But more importantly than that, with active chipsets inside of these cables, it's incredibly important that we have a trusting relationship with the manufacturer, because this also becomes a security issue. If you thought that security on boxes was challenging, wait until we start dealing with security on chipsets embedded into cables. And of course, there's no more advanced cable, no more advanced capability than what we're seeing in Thunderbolt 4, which gives us the ability to have 8K HDR or dual 4K HDR capability. Now, I got to ask you this. If a typical worker, if a typical client, if a typical student is capable of looking at dual 4K monitors in their house, and by the way, dual 4K monitors, this is like a $600 investment, right, to put on your desktop. If I can do this in my office and I go into one of the most sophisticated companies and walk into your conference room and I'm still faced with a VGA connector, what does that say about where we are in this industry, right? So understand that Thunderbolt, here's one of the challenges I see coming out of the industry right now. How do I get this cable longer? I need one of these that's 30 feet long. How is Thunderbolt different than USB? Well, understand Thunderbolt is the supreme expression of USB 4, and it allows us to have the most capability. So this is a USB Type-C cable, but we are hard limited at this level of performance to about 1.5 meters or 2 meters. So now we have to be able to apply docking stations as a demarcation point. And understanding EMCA cables and docking stations that we've typically put aside as, well, that's personal technology. That's not part of the AV design. I put a poke through on the conference table, or I put something on the podium and you connect it. The docking station has to be a part of the design. And when we look at USB, forget about 1.1 and 2.0 and 3.0. Those are, they're defunct, they're gone. Everything is now under the umbrella USB 4, not a 4.0, USB 4, that's the name of it. And it combines USB 3.2, Gen 2, DisplayPort 2.0, Thunderbolts 3 and 4, all into a single standard that describes real performance. The reason that I bring this up, the reason that I focus on this so much is up until a couple of years ago, discussing USB wasn't even part of an AV curriculum. We didn't see classes on this. We didn't look at this technology. Yet we all know that you cannot do an interactive flat panel, an interactive projector, or an interactive kiosk without USB. This is how human interface devices operate. And it just became also the carriage point for content. That is an emerging technology. And what's more than that, it is a requirement for us to understand this is an emerging technology. One of the things that is so incredibly important about this also is we start seeing changes in consumer technology that are going to find their way to corporate technology. So we take a look at something like HDMI 2.1. This is real. This standard was accepted and ratified in 2019. We're beginning to see products now. As a matter of fact, I believe that the keynote speakers from Crestron brought up specifically that Xbox and the Sony PlayStations are now HDMI 2.1 capable. We're going to be seeing this in a lot of devices. What does HDMI 2.1 bring to the party? Well, suddenly we have to understand HDMI labeling conventions. We have to understand active cables because HDMI 2.1 requires active cables. We have to understand a little bit about how do we power those active cables. There is, in fact, an ability to have a powered cable port on these cables, part of the HDMI 2.1 standard, but it really hasn't been implemented. And I just want to point out to you that we have an entire series of white papers and ancillary materials in our links for today's session. There is a white paper just published, which is called the Ghost in the HDMI Machine. And if you really want to understand the challenges that HDMI 2.1 are going to bring to you, that white paper is there for you. We also have another white paper, Understanding USB Type-C and Docking Stations, that takes you through EMCA's length limitations and payloads. Once again, I think this is an incredibly important technology for you to take a look at, and those have been put into the system for you to be able to look at those at some future point. But HDMI 2.1, don't take this lightly. When it ends up in a kid's gaming system, it will end up in the corporate presentation systems in the not so distant future. I remember people telling me we're never going to use HDMI in our solutions. This was circa 2011 and 2012. And it was already the default standard in residential installations. When was the last time you saw a commercial installation that didn't have an HDMI link? It's only been a decade. And the entire AV world has changed. HDBaseT 3.0 has also been accepted as a new standard in 2019. It changes the HDBaseT capability to 18 gigabits per second. And here's one of the things that I think is so unbelievable about this technology, which I'm sure you're going to recognize as the backplane for so many switches and so many other devices that are out there. This now allows simultaneous carriage of gigabit Ethernet, as well as USB 2.0. Well, what does that mean? I want you to imagine this. Let's say that I was doing a major installation and I wanted to be able to put in a giant projection system, 2K, 4K, it doesn't really matter what the resolution is, but I'm putting this in an auditorium, I'm putting this in a cafetorium, I'm putting this in a gymnasium or whatever the case might be, but I also want to have smaller monitors on the way to the concession stand. We can now run a single home span category 6A cable and run uncompressed high definition video with embedded audio and simultaneously run AV over IP in the same cable. That's a big change in AV technology. We begin to see how this convergence of AV and IT really is muddying the waters, but let's not make this mistake that somehow everything becomes IT. We still have to have pictures. We still have to be able to film things and have a microphone. We still need to be able to play them back. And that requires convergence at both ends. HDBaseT is an ideal solution for premise wiring point to point, where AV over IP gives us the ability to actually have much larger scaling, but we have to be a little bit more careful about the bandwidth that we're expecting in an AV over IP kind of a solution. And if my slide changes, I'll probably talk to you about AV over IP next. I believe that's the next one that's on this slide. And there we go. When we start talking about AV over IP, we really have to think this way, right? The traditional AV switcher, fixed number of inputs and outputs, and that is great if we can determine the necessity of connectivity ahead of the design. But when things grow and change, these kinds of fixed systems can be, well, constricting, right? They can keep us in a spot. So we want to be able to take this and put this over an IP network. And I apologize, my dogs are now going to start barking. So I'm going to send this one out to another room because there's probably an Amazon delivery guy. This is the fun of us all working remotely, isn't it? Okay. AV over IP isn't just one system. And if you haven't been interrupted by barking dogs in the last year, then you haven't been working. AV over IP isn't just one system. AV over IP is one concept, but it embodies a multitude of systems from H.264, H.265 compression, everything from JPEG 2000, SDVOE, of course, which is optimized for 10 gigabit Ethernet. We really have to decide up front when it's AV over IP. What are the limitations of performance that we're ultimately going to put into this kind of a system? And where do we want it to be? And I wanted to share with you, I think, one of the more exciting new technologies, and there are a number of them coming out when we talk about AV over IP, but I think AVX is actually pretty exciting. This is all about the extension of audio, video, gigabit, Ethernet, and control signals between individual devices. It doesn't have to use a switch for this to be able to operate. It can be point-to-point wiring, which I think is kind of interesting, and it can do some phenomenal distances, up to 40 kilometers over single mode fiber, up to 550 meters, a half a kilometer over multi-mode fiber, and easily up to 100 meters over copper. So it gives us this ability to really transport a tremendous amount of information up to 4K 60 10-bit in a 422 color space. So essentially what you're seeing from Blu-ray DVD players is what this is capable of. A new variation in AV over IP, just one of the things to keep your eyes open for and your imagination open for, because we're going to see these kinds of technologies really impact our market as we move forward. So I just kind of want to summarize what I have, in addition to talking about dogs that are barking as we get interrupted from all of the various things as we work remotely. But the reality is what we just talked about today are the four vectors of human communication, device to device, the machines talking to each other. This is the essence of AV design. Human to machine, how we control this. We never thought about this years ago. It was a control panel. It was push buttons. It was some kind of a device. But today we can control devices by proximity. We can control them by geofencing. We can control them by gesture. And of course, we can control them by voice. And it's so important that we bring those capabilities to the commercial sector because they are expectations from the users. When we think about future emerging technologies, 5G, it will have a profound effect on us culturally at some point in the future, but I think it's going to have very little direct impact on AV design in the near future over the next 5 to even 10 years, other than it will open up new markets to higher bandwidth communications like this. More importantly, HDMI 2.1, DisplayPort 2.0, we're seeing now AV transport that exceeds the bandwidth of any kind of a LAN. And if we don't understand USB Type-C, which is, of course, universal serial bus, but it's only universal if you truly understand how it operates. USB Type-C is going to be the connector for every AV source device. And if you've not adopted this to your future AV designs, you're already behind the 8 ball. You're already behind the curve. EMCA, electronically marked cables, embedded technology, these change the ideas of smart. These pieces of wire are now components. HDBaseT in the premise, AV over IP when we need unrestricted scalability in much longer distances. This really gives us, I think, the summary of the emerging technologies that we're going to see impact our business over the next year to perhaps 3 or 4 years out.